How would I start the first problem in the warm-up today?
Square root.
Okay, I heard two different methods. They actually both work. Someone said just take the square root of both sides. That would give me x equals plus or minus 4, right? Anytime you take the square root, you have to say plus or minus. The other way to do it, I'll do it in a different color, I'll do it in red, would be to subtract the 16 from both sides. Then you could factor. You'd have x minus 4, x plus 4. When you set those each equal to 0, what do you get? Yeah, you get the same thing. Okay, so either method works here. Any questions on that one? What about the second one? How could we do that one? Yeah, you could do it the same way. You could add 21 and take the square 121 and take the square root, or you could factor it to x minus 11, x plus 11. Set each one of those equal to 0. And what do we get here? Plus or minus 11. Very good. What are your questions about this? Either method works. It's up to you. So today we're doing section 5.3. It's solving quadratic equations by finding square roots. Our goals are listed below. We're going to simplify radicals, and then we're going to solve quadratic equations using the square root method. We did that on both of our warm-ups. We did it on an example yesterday. We're just going to look at a little bit more challenging ones today. But this is definitely something you guys have already seen. We've already done in this class. We're just going to look a little more in depth. So to simplify the square root of 60, do you guys remember how to do this? Teachers teach it in different ways. So how did you learn it previously? Yes?
Like you can do a factor tree.
Very good. A lot of teachers tell you to do a factor tree. Whoops. There we go. So I need to do a factor tree for 60. So how could I break up 60?
2 and 30.
2 and 30. 2 and 15.
3 and 5.
3 and 5. Good. Now you circle the pairs. So here's a pair of 2s. And when I say circle of pairs, you look at the bottom of every branch. Once you get to a prime number, that's the bottom of that branch. So the 2 is the bottom, the 2 is the bottom, the 3 is the bottom, the 5 is the bottom. We have 2 2s. So a 2 is going to go out front on my radical. And then I'm left with a 3 and a 5. Well, what's 3 times 5? 15. This should look extremely familiar. Do you guys remember doing this? Okay, good. He said, is there a simpler way? Some teachers just think you to think of perfect square factors. Perfect squares are 4, 9, 16, 25. You can see that 4 goes into this, so you could rewrite it as 4 times 15, and then the square root of 4 is 2. So that's the other way to do it. A lot of people do the factor tree. How would we start number 2? Any ideas? Yeah, let's do 18 times 2 first. What's 18 times 2? 36? Do we know the square root of 36? 6. Yeah, you don't even need a factor tree for this one. It's a 6. Anytime you have a fraction under a square root, you can take the square root of the numerator divided by the square root of the denominator. What is the square root of 81? 9. What's the square root of 121? 11. Great. What are your questions on simplifying radicals? Like I said, we're not going to spend a ton of time doing this. I'm assuming this is something you're pretty comfortable with from your years in Algebra 1 and Geometry. Do you guys have any questions on what's on the board? All right. Now we're going to look at solving quadratic equations, and we're just going to concentrate on the square root method. We're not going to factor a lot today. So using the square root method, how would I start to solve this? Add add 5. When you're doing the square root method, you want to get x squared by itself. So I'm going to move the minus 5 by adding 5. That's going to be 4x squared equals 4. Then what? Divide both sides by 4. So x squared equals 1. Then what do I do to both sides? Square root. Anytime you take the square root, what do you need to put? Plus or minus. And what's the square root of 1? 1. Great. And again, we know now where the plus or minus comes into play, because when we factor this, we'd have a difference of 2 squares, so we'd have a plus term and a minus term, so when you solve them, you get a plus or minus 1. So it's kind of interesting after you see why you have both, once you know how to factor. Any questions on this? All right, here's number 5. All right, any ideas where you guys want to start on this one? Yeah, let's subtract 12. Remember, we're trying to get the x squared by itself to take the square root. Then what? Good, divide both sides by -2, so I get y squared equals 4. Then what? Yep, so y equals plus or minus 2. Great. Now, you might be asking yourself, well, when am I going to use this and when am I going to factor? That's a good question. You could have gotten everything to the left side in this one and then factored. You should get the same thing. I would recommend using this anytime there's just a variable squared and no to the first power. So if you see y squared and no y, this is a perfect time to get everything away from the y squared and then take the square root. All right, but again, you could get everything to one side, use difference of squares if you wanted. You should get the same answer. Any questions?
Is this all we're doing today?
The question was, is this all we're doing today? They're going to get a little harder. So, yes, this is all we're doing today, but they do get a little more challenging. All right, here's number 6. How am I going to start number 6? Add 3, good. All right, then what? Multiply by 4, good. What is 36 times 4?
144.
What is it, 144? All right, then what? Square root. Square root. So what's p equal? Good, plus or minus 12. Great. What are your questions? This one's a little different. Any ideas how we could start this? The whole left side right now is being squared. What do you think? You could write it out and double distribute, but let's try to use the method we've been using all day. Yeah, you can take the square root right now. So the square root and that squared on the left both cancel out. You're just left with y plus 3 equals 3. Good. Regular 3? Plus or minus 3. Good.
And you can't carry the subtract 3 or anything.
What? Sorry, say it again.
So the y plus 3 doesn't, so you can't like carry it over to the other side and have y equal whatever.
Well, yeah, now we're going to subtract 3 from both sides. And we have y equals. Now, anytime you have a plus or minus, put that in the middle of the two numbers. So we'll have -3 plus or minus 3. Well, let's work it out. What's negative 3 plus 3? 0. What's negative 3 minus 3? Negative 6. Done. So when you get to something like this, if you can add and subtract them, do it. Negative 3 plus 3 gave us 0. Negative 3 minus 3 gave us negative 6. Sometimes one of them will be in a square root and one won't, so you just have to leave it plus or minus. But in this case, we could actually work it out, so work it out. Now, you could have done y plus 3 times y plus 3, double distributed, subtracted 9, factored, and you should end up with the same answer. But I think this is a lot easier. Any questions? All right, here's number 8. Any ideas where to start on 8? Yeah, divide by 2 and divide by 2. So I have y minus 3 squared equals 4.
X minus 3.
Yep. That's what I meant. All right, what do we do now? Square root, good. So the square root and the squared undo each other. So we have x minus 3 equals plus or minus 2. Good. My next step is to add 3 to both sides. Good. So I have x equals positive 3 plus or minus 2. So what's 3 plus 2? What's 3 minus 2? 1. So 5 and 1 are my two solutions. Questions on these? All right, so we're back on number 9. Any ideas? Yeah, we got to get rid of that 1/4 out front, so we're going to multiply both sides by 4. So I still have the b minus 8 squared equals 28. Good. What do I want to do to both sides? Take the square root. Good. So I have b minus 8. No more squared, so I actually don't even need the parentheses. That's going to equal plus or minus the square root of 28. Can I do anything with the square root of 28?
You can break it down.
You can tree it.
Yeah, you can tree it if that's your, what do you want to call it? Good. What does 28 break down into? 4 and 7? 2 and 2? So right now I have b minus 8 equals plus or minus, what goes in the front? 2, because I have 2 of them, and then square root 7. And then how would I finish this up? Add 8, good. And again, I want the 8 in front of the plus or minus. Now, a number inside of a radical is kind of like thinking about like terms. Are these like terms right now? If I had 8 plus 2x, could I add them? No, it's the same idea. This one is just a number. This is 2 times a radical. Unless it's the exact same radical, you cannot add and subtract them. Okay? So don't make this like 10 square root 7. A lot of people want to do that. It is not mathematically accurate. Okay? So that is the answer. That's as far as we can go on this one. If it says approximate to the nearest tenth, then you could type it in your calculator. But I want exact answers, so just leave it like that. Any questions on this one? This is kind of the hardest one we looked at today. All right, that's all I have for you. Here's your homework assignment. We're only doing this lesson for one day, kind of different than the last couple where you had 2 days. So try to get this done by Monday. Again, we'll be in the lab Monday. I'll still take questions over this Monday, though, if you'd like to go over it. You have a quiz over this material next Thursday, so be aware that that is coming. We'll do this graphing activity Monday and Tuesday. Wednesday is a review. Thursday is a quiz. So be prepared for that next week. Any questions?